Hello, hello, Objective by the Sea. Welcome to our talk titled Mac, Where's My Bootstrap? This talk is on leveraging LaunchD as a data source for detection of XPC logic exploits. My name is Brandon Dalton. I'm a senior security researcher at Microsoft. I focus on OS internals and now more recently M365 researcher as well. I am probably most well known for in the circles as the developer of Red Canary Mac Monitor. I'm also an attack contributor. To me, family means everything. I love to travel, and I love history. And I'm ready to pass it off to Csaba.
Thanks. So my name is Csaba Fitzel. I go by the evil bit on X. I currently working as a principal macOS security researcher at Country, mostly doing offensive research. I also the author of the EXP312 training at OffSec for macOS exploitation. I do macOS bug hunting and offensive research, close to 100 CVs. I'm married, have 2 kids, and I really love hiking and trail running. So let's see what we will talk about. So we will talk about LaunchD, but in a context of how to detect XPC attacks in a generic way. So we will run through quickly some XPC vulnerabilities, how they are being attacked, then our idea for the detection, then we will deep dive into LaunchD and why we need that. For the detection, we will drop some tooling, demo, and recommendation. So let's start. How it started. So first, what is XPC? XPC nowadays is the primary method for doing cross-process communication between processes on all of the OS devices. It's based on Mach messages. Usually in our context, we have XPC clients and services. Usually these XPC services are privileged non-sandbox services. Think about all the privileged helper tools installed by third-party application, which are usually used for like software update, installing licenses, moving files, whatever. Usually these are privileged action which cannot be done by the actual application which runs as the user, which is again typically non-privileged. So what's the problem with these services? So by default, they are global services, and everyone can reach them on the system. So by default, nothing prevents me to reaching out to this service and saying that, hey, you are a software updater, please install this package, and boom, you have an LPE on the system. So if the client access is not controlled by this service, we are looking into an abuse there. And the main problem with this is that client validation, although it's really easy and it's only a few lines of code, it's very, very tricky, and it's very, very easy to miss some items. I think Apple doesn't provide a good secure coding best practice for how to do this securely, so it's also hard on the developers to do it right. So let's see what's needed to make an actual secure XPC client validation. If we miss any of these points, then it's usually open for an abuse. So first of all, we need to check if the connecting client is signed by a certificate which was issued by Apple, so it's like a valid developer certificate. Because if not, I can just use a fake root certificate and impersonate anything else. Then I need to check the bundle ID of the connecting client because I only want my application connecting to the service. I also need to check the team ID because anyone can get a developer ID, and anyone can fake a bundle ID, and then anyone can connect to the service. We also need to check the app version when connecting, or we need to verify very strictly the client entitlements and if it's sufficiently hardened. Because if the client is not hardened, so it was not signed with a hardened runtime, or it has some entitlements which allow dilib hijacking, which we saw yesterday at Wojciech's talk, it means we can inject into the client and then talk to the service through the client. So we need to ensure that only recent and fresh, up-to-date clients talk to this service. Otherwise, I can just grab a really old app from Mojave and use that. And last, we need to use the audit token for all these code signing validation and not the PID. Actually, this is only possible since Ventura, because before that, we didn't have a public API for that. So again, all this allows RPs, data compromise, business logic compromise, so maybe you can just disable the antivirus or anything like that. And it's really, really easy to identify these weaknesses and also to exploit them. And there is no shortage of XPC vulnerabilities. And this is like just the tip of the iceberg. I think nowadays it's not that well spoken, but they are still coming. So for example, this is an old vulnerability. It was impacting Microsoft Auto Update. Basically, Microsoft did everything right. They validated all the code signing requirements properly, except the version. So I could just grab a macOS Auto Update app from macOS Mojave time from back, I don't know, 2018, inject my code into it, and then talk to the update service and install my own package. So the idea is now we have an XPC event in Endpoint Security since Sonoma. Let's use that to actually detect XPC attacks. The only thing we need to do is basically the same validation. We want to ensure that the client and the service are signed by the same code entity, the same developer. And if there is a match, then everything is good. So should be easy peasy.
That sounds pretty easy, Csaba. Unfortunately, I don't necessarily think that's going to be the case. So macOS is going to give us an XPC event. Let's dig into this event and see what it actually delivers to us. So if we look at the endpoint security event explicitly here, we see it gives us two properties, an ES string token T and an ES XPC domain type T, the service name and the domain the service is living in. And this is important to note that these are XPC services and not LaunchD services. On the right there, you'll see an enumeration of the different domain types. I'll go into this a little bit later. But below, you'll see two examples of endpoint security emitting an event. And when using a third-party client, it might be a little bit more helpful, because on the right there, you just see that, hey, service domain type is 1. But we could also enrich that and bring out that, hey, that's the PID domain. So let's take this out for a test drive and see what this yields. So I wanted to first create a simple test here. So created a LaunchD service, and you can see in our mock services dictionary there on step 2 that it actually has the same name as the LaunchD label. We're going to register this with the Bootstrap server, LaunchD, and you'll see that it appears as a service in this dictionary here. We're then going to look up this service using XPC connection mock service, create mock service. And at this time, when we look up this service, if it's in the valid domain, endpoint security will emit an event. One very important thing I would like to spell out here, this does not mean a successful connection, it just means this, the service was able to be looked up. All right, so great. Now where's the path? Csaba said we have to check the code signing. Introducing the Bootstrap server. This is where we're gonna try to enrich our data with and get some more information. So on macOS, the Bootstrap server is LaunchD. It's the manager for these jobs and XPC services. And so it has to know where the program path lives, correct? Unfortunately, this isn't always as straightforward as we're going to see over the next few slides here. But I wanted to introduce the idea of LaunchD domains. And these essentially enable privilege separation between helper tools. So the system domain, I'll just walk through these really quickly. The system domain is a privileged domain for first and third-party services. The user domain is rather a delegated domain, so a logged-in user doesn't actually need to be logged in. It can just run on behalf of this user. Then the login domain is actually specifying which type of login session. So like think GUI login, Aqua, SSH session, Telnet, all the rest. The GUI is actually a convenience domain for a specific type of login session. If it has an Aqua session, you'll be able to reference it with this GUI domain here. And the PID domain, every process on macOS is given its own domain. And you can kind of see how this materializes on that diagram on the left there. So you'll see that every service has a send right to the Bootstrap server, and the Bootstrap server can receive these requests. And one thing to spell out here is, these domains are nothing but a twisted figment of LaunchD's imagination, like Jonathan Levin kind of spelled out here. Okay, so that sounds pretty good. It seems like LaunchD has all the information we're going to need. Let's go ahead and try to actually use this to find what we need. So we all know about launch control. This is that command line utility that enables us to communicate with LaunchD and pull back these specific pieces of information on either a domain target or a service target. And what's very important to mention here is this is not an XPC service. This is a LaunchD job. So for example, if you notice at the top here, we're printing out a service target in the PID domain. And then you'll be able to see there's a program path associated with this service, and it hosts a bunch of endpoints. And these endpoints are from the advertised launchd.plist for this job. And these endpoints correspond to the XPC service names. So the yellow circle there is what we're essentially trying to look up. And thankfully, Jonathan Levin also produced LaunchJ control, which enabled us to kind of get some more programmatic resolution into this, since launch control is closed source.
Yeah, so Jonathan Levin did a great job reversing launchctl and finding out how to programmatically query LaunchD. Now, unfortunately, it's kind of broken. So there are many messages, many lookups we can do with LaunchD. Some work, some doesn't work. We love the consistency here. So what used to happen is we send an XPC pipe routine to LaunchD, send the message, and we send a reply, and LaunchD will populate all the information back in the reply information, which is kind of gone. In some cases, this still works this way. In some cases, it works another way. So what happens now with some of the queries? We still send an XPC pipe routine with the message and the reply. We still get a reply, but in the message, we also send over an XPC shared memory. So we create a shared memory, we put the address into the message and send it over. LaunchD will find out the information we need, and it will populate, put that information into the shared memory and send back the reply. And inside the reply, it will tell you how much bytes it wrote inside the shared memory. Now, it's not a structured data. It's like a C string.
So to kind of visualize what Csaba just said there, there's two main operations that we want to get access to. We want to be able to print a service target and print a domain target. And we'll fill in an XPC dictionary to go ahead and do that. And like a previous talk mentioned as well, we're going to use that undocumented XPC pipe routine over the Bootstrap port using mock task self, or it's the first port returned from mock ports lookup. And we're going to want to parse this blue blob. And for those of you that are familiar with launch control, this looks very similar to the output from launch control. And that's because it pretty much uses that same backend that launch control is using. And unfortunately, this structure is really not easily serializable or parsable. You're kind of limited to string parsing at this time. And so Apple must know that this is a barrier to entry to creating an open API. So what are those special keys to kind of request information from LaunchD? This is all undocumented, not easily, easy to figure out. So there's 5 main keys here that you're going to want to specify. The first is the type, which corresponds to that domain. The second is the subsystem, which specifies, are you talking about a service target or are you mentioning a domain target? And we're also going to need to use a handle in certain cases because we need to specify which domain we're talking about, right? For the PID domain, we want to have that PID in there. For the GUI domain, maybe the UID is important. And the routine is that specific command within the subsystem. So think launch control print, launch control list. All these are specific routines. And optionally, you'll need the name if you're specifying a service target. Once we have this filled in, we create our XPC pipe using the Bootstrap port, and we send that over XPC pipe routine to request that information from LaunchD. So what does that actually look like? Unfortunately, it is a little complicated. So if you see that initiating group ID at the top there, this comes from Endpoint Security, so we can use this almost as a convenience factor. So we'll look up this PID domain. So I'll look up PID 55860, and that will return me all the services that live in that domain. I'm then going to have to parse through each one of these endpoints and look up its service target to find a matching endpoint which has that XPC service name. So, for example, this one from 1Password is a really good example because the launchd job type, label does not match that XPC service name. So there's really no good way to look this up using launch control. So we're instead having to resort to kind of iterating through each of these service targets. And you can kind of see the flow chart there just for the PID domain. There is a much bigger flow chart that I was going to originally show, but it's a little scary. So you guys can revert to the code for more information there. But now talking a little bit more about that code, so we would like to release a free tool for everyone to kind of use and kind of pull back information on these XPC services and help it resolve that path. So this is an endpoint security client that you can go ahead and download. It is distribution entitled. It's GPL licensed. So you can actually go ahead and start ingesting these XPC connection events and have it start resolving those service paths for you. And most interestingly, it's also going to implement a rudimentary detection for us here. And so this is just that top level detection, but our client actually goes into a little bit more detail here, and you can kind of look at that in the code. So essentially what we're trying to do is say, is this service Apple or not? Because we're not caring about Apple services. We're mainly concerned about the third-party abuse here. And then we want to check the code signing on both ends, correct? And for that, we need the path. And that's something that Endpoint Security just does not provide for us. So now I'd like to pass it over to Csaba to go through a demo.
Yeah, so luckily we have an XPC O-Day here, thanks to Chris Lopez. It's up on our website, so we will use this example as for detection. Okay, so here's a video. The POC is running the detector, and we will launch the exploit. And there we go. We have one detection. I will let it run and then stop because there is a second detection coming as well, which is actually related to the exploit itself. So let me stop this before this appears. So again, the first detection, we can see that there was a connection from a process called Twitch XPC client, which is of course fake, and that's our exploit, connecting to the privileged helper of Twitch, which has a team ID. Our exploit didn't have a team ID, but because they are different, there is detection for that. The second case is where the exploit is actually replacing the privileged helper tool with something called pwned, and when we trigger the XPC service again, it will be launched, and we can now detect that there is some fishy XPC service as well without team ID, which is really bad in its own. So yeah, pretty much.
Yeah, so lastly, this is not an ending note. We do have a few suggestions or requests from Apple to help us kind of make this process a little bit easier. We shouldn't have to necessarily jump through all these hoops as EDR developers to kind of help protect users from abuse of XPC exploits. So really just including that program path of the XPC service there would enable us to kind of do that code signing lookup. But then taking that a step further, also including the team ID in that XPC connection could also help us out there. Yes.
Yeah, and everyone does one more thing nowadays, so we will do one as well. I genuinely think that this is the original guy for the just one more thing. I'm not sure how many of you see his series. So actually, I was thinking about for many, many weeks now, talking to friends, colleagues about this, and also to a lot of people. And I actually decided to go down the route, and I will come back with a macOS vulnerability research training late next year or early the following year, done by me and live only, so it will not be like an online class or book or anything.